Hello students, so today we will be discussing about a very important metal oxide called titania. Its chemical formula is TiO2. Now titania is found in three different forms. The first one is called uh, brookite, which is having an orthorhombic structure, and the other crystallographic structure is tetragonal. However, in the same tetragonal structure, two different phases of titania can be found. One is called the anatase, and the other one is called the rutile. So we will address them as B, A, and R. Okay. So we have the brookite, the anatase, and the rutile phase of titanium. Now, out of which this phase, rutile, is a high temperature phase. So that means we have a B or A phase, and if they are subject to high temperature, rutile phase is formed. Now this titania again can be found in the form of powders or nano-sized powders, so which has applications. So we are now talking about nano titania. This nano titania has applications as pigments, as absorbents, catalyst, and as sensor, humidity, and gas, and it is also used as self cleaning coatings. These are some of the applications of titania, especially nano-sized titanium. Now this the anatase phase and the rutile phase are the most common phases. And now this anatase phase is having photocatalytic properties. Although rutile phase also has photocatalytic property, but the anatase has a higher photocatalytic activity than rutile. Whereas the rutile phase is more suitable for pigments, white pigments, And then since it has a high refractive index, it has got high weatherability, that is oxidation, and wear resistance. So oxidation and wear resistance. It's comparatively inert or more stable than it is phase. So it's thermally as well as chemically more stable than the anodized phase. And this rutile phase is also used in products of sterilizing deodorizing and anti-fouling properties, and it is also used in a special type of chemical solar cell called 𝗧𝗶 𝗧𝗶. Cell is a special type of chemical solar cell. We'll take the 𝗧𝗶 cell in details somewhere later. Now, this anodized phase, as we have said, it has got photocatalytic activity, but this photocatalytic activity is more prominent in ultraviolet light. So whenever you need to clean water, you need to have a certain supply of UV light. However, with doping, the help of doping with some foreign metals as well as non-metals like carbon, it is possible to stretch down the photocatalytic activity from usable to this. So the visible light may also lead to some photocatalytic activity in anodized phase, provided it is doped with the appropriate material in an appropriate manner. Now this titania TiO2 has a potential to carry out a process called hydrolysis, that is basically breaking of water H2O and broke down into H plus and O2 minus, where H plus hydrogen ions are used for energy production. This process is known as hydrolysis, and TiO2, since it is a photocatalytic process, similarly the same ability makes it to be used as used for hydrolysis of water. Now, there are different ways of synthesizing this titania. For example, there is a process called chemical decomposition. Like sol gel, then chemical vapor deposition, then microemulsion, as well as hydrolysis. However, the morphology or the geometrical configuration of titania obtained from these synthesis methods are different. There are different ways by which you may get titania. You get the titania as spherical shaped powders. Then it can be obtained as thin films. It can also obtained as nano rods or nanowires, which are basically one-dimensional nanomaterial. Now, if you concentrate on the synthesis methods, especially you need to have, especially the chemical methods, a very obvious requirement for producing titania by chemical methods is having a suitable precursor or the starting material. Now, this precursor can be different for different methods. For example, if you are producing titania through sol gel, you can use a precursor 𝗧𝗶𝘁 titanate. Now, this 𝗧𝗶𝘁 titanate, when calcined, calcination is a process where, with the help of high temperature, like in this case, the different phases of a material gets evolved. Now, with the help of this calcination, anatase shows initial phase of the titania. It gets converted into rutile, but in the nano form. Its like size are in the nano range. It's called the nano powder form. So, although a phase change might have taken place, but the size of the titania also changes to nano form. Now, different combination of precursors can be used. And the advantage of using sol gel is you don't require very high temperature. It can be used at a lower temperature. Catalyst in this case is HCl, and the ratio of HCl and water is taken as 50%. And the next important method in the sterilizing or step is the stir. This is also a very important method because it leads to the homogeneous solution. The mixing is well and can lead to homogeneous solution. Now, this homogeneous solution or the gel that we obtain after the stirring, it is dried in air. Dry in air. After drying, we get a viscous wet gel. That means it is containing water, viscous wet gel. Now, this viscous wet gel is again oven dried at a little bit higher temperature to remove the water for a long duration, usually 10 hours, to obtain what is called as prepared sample of titanium. And the ratio of the different ingredients, I mean the ratio of the precursor is to solvent, is to the catalyst, and water. They are very important. Usually the issue is kept in the same order as 1 is to 15 is to 0.3 is to x, where the water content can vary from 1 to 4. And the catalyst, as previously told, is HCl. Now, when the water content reaches the maximum limit 4, there is the influence of changing the catalyst to acetyl acetone. So instead of HCl, when the water content is 4, the catalyst gets changed to needs to be changed to acetyl acetone. Now, as we have said that nanorods or nanotubes can be formed, that is one dimensional titanium structures can be formed through these techniques, and the advantage of having this one-dimensional TNT is having a large specific surface area. That is surface area per gram. When we are talking about anything specifics, with the prefix specific, we mean per gram. Now, having these large specific surface area per gram, it leads to an enhanced photocatalytic potential. And also increases the material's ion exchangeable property. It becomes more like an ionic solvent. Now, there are different ways of producing this one-dimensional nanotubes of titanium. There are three principal methods, three main methods. One is called the template based synthesis. The next one is the hydrothermal treatment. And the last one is electrochemical anodic oxidation. Now, template assisted method is used in making nanoporous membranes. Rather, nanoporous membranes are used in making template build analysis, and these membranes are made up of anodic aluminum oxide AAO. Anodic aluminum oxide. These are arrays of parallel straight nanopores with uniform diameter length, and thus serve as a template for growing nanotubes. So these are the different pores. So nanotubes are formed inside these pores. They are periodically arranged. Now, if we compare, there are two different methods. There are in fact three different methods that we have talked, like template method. Then one is your electrochemical anionic oxidation. And the last one being hydrothermal. So there are three different ways of producing titanium nanotubes. Now these the three have their own advantage and disadvantages. First of all, let me first talk about the features of TNT obtained. So in the first two cases, the TNTs are pretty much ordered, but in the first case, in the template case, it is formed in the form of powder, whereas in the second case, it is formed as a film, the form of a thin film. Okay. In the third case, in the hydrothermal case, also it is in the shape of a powder, but it is not like the template case, because in this template case, the ordered arrays is in the form of ordered arrays, whereas in the case of hydrothermal, it's quite random. Now this hydrothermal is probably the most suitable form of TNT generation, because we have the control over the TNT, the tube characteristics. That means with the help of temperature, then time, and the precursor, the length of the TNTs can be varied in hydrothermal treatment. However, compared to that, if you look at the template bed assisted methods, here also the scale of the nanotubes can be controlled, but not to the extent as in the case of hydrothermal treatment. Also in the case of template, it's a little bit complicated, and the tube morphology may get destroyed. In the case of template assisted deposition. Electrochemical anionic arc, let's call this one as EAA. This EAA method has the advantage of getting an ordered structure, like we get a thin film here, but it is also ordered, and the aspect ratio is very high. And the disadvantage is that although EA may be efficient in producing highly ordered structure, but it put little limitation on mass production. You cannot produce a large quantity of TNT. So mass production is limited. And that's got a little bit of rapid formation kinetics, and rapid formation kinetics also depends upon how well you are utilizing the catalyst, that is HCl or HF. It's a little bit dependent on that. The hydrothermal treatment is, as told previously, it is supposed to be the best technique to produce a large amount of titanium nanotubes, and it has got a lot of scope of modifications as well. the hydrothermal. You can increase, you can different types of impurities. The only disadvantage that, not only, I mean, the one of the disadvantage that this hydrothermal treatment has is it takes a lot of time. So the long reaction duration is one of the disadvantages in hydrothermal processes, and you require a little high concentration of the material. Like if you are using an NaOH, so the concentration of NaOH in hydrothermal synthesis is also high, and you compromise, although you will produce the material in bulk, but since the titanium powders are randomly aligned, so getting a uniform size is really difficult. So difficulty in getting a uniform size. So